Hello everyone. There are many kind of motions around us, like the motion of the earth around the sun, the motion of moon around the earth, or the rotation of the earth on its axis, or formation of clouds and rainfall. There are many such motions around us. These motions can be categorized into two types called as periodic motion and then aperiodic or non-periodic motion. As the name tells us, periodic motion means something which repeats itself. So let's define it technically. Periodic motion means motion which repeats itself after a regular interval of time. That is called as periodic motion. Now, since the motion repeats itself, there will be a time interval between the two motions. That time interval, which is regular, is called as time period of the periodic motion. Means that motion would repeat itself after the time period. In this periodic motion, there is one special type of periodic motion which is called as oscillatory motion. Oscillatory motion is a special kind of periodic motion. So let's look at the definition of oscillatory motion. So we can say it is the periodic motion in which a body moves to and fro about a fixed point. That is called as oscillatory motion. Here it's given as to and fro. Let's understand this. For example, think for example we have a case where there is a string like a thread, or let us take example of a spring to which some mass is attached. Now here let us take the center of the mass as the reference point for the system. The reference point could be anything. Here we take the center of the mass. Let's call this reference line as A. If some force is applied onto the spring mass system, that is, if somebody pulls it, then it would extend. Let the extended spring be something to this level. So the spring mass system has been extended from level A towards level B. If the force is removed, then this would oscillate. It will start from point B, it will cross point A, it will go to some point A, like this. Which means the spring mass system would oscillate between the points B and then C, passing through A. This A is called as mean position or equilibrium position. We can say that this is a position at which the mass would come to rest when the force is removed. If you assume that the spring starts from point C, then we can take the motion from point C to point A crossing to point B crossing point A as two motion. The motion from C to A is taken as two motion. Then the motion from B to C is taken as fro motion. So two motion is from C to B and fro from B to C. Such kind of a motion is called as oscillatory motion. Now note that all periodic motions need not be oscillatory motion, but all oscillatory motions are periodic motions. Let's look at some examples of periodic motion. First example, the revolution of the earth around the sun is a periodic motion. That is, if we assume that sun is present somewhere here and the earth moves around the sun in elliptical orbit, so this motion would be a periodic motion which time period of 1 year. Similarly, The moon revolves around the earth with a time period of 27.322 days. Even this is example of a periodic motion. Also, the motion of hands of a clock are periodic. In case of a clock, there are three kinds of hands called as seconds hand, minute hand, and then hour hand. So if we look at seconds hand alone, this would start from some point. Let's assume that starting from 12, it will cross all the possible points and come to the same position. So this needle or this hand has made a complete rotation. So even this is a periodic motion. In this case, for seconds hand, it will be 60 seconds. Similarly, the minute hand also would start from some point. If you assume that it starts from this point, even this also would cross all the points and go to the same position. In this case, the minute hand comes back to same position or repeats after 12 hours. So I'll find out what is the time period for a hour's hand. One example is given here. It says that if an insect climbs up a ramp and comes back to initial point and repeats the process in the same manner, taking regular intervals of time, the displacement time graph looks like this. Now remember that a graph of displacement versus time for a uniform speed would be a straight line. Understand this? Let's take that there is like some kind of a ramp like this, and imagine that, or some kind of elevation like this. Imagine that an insect starts from some point, starts from here. Let this height be some 5 meter. So let's assume that the insect moves with uniform speed. So it will keep on covering. Let's assume that the insect starts from the lowest point and goes to highest point in 10 seconds. It starts from here, it crosses and goes here in 10 seconds. So the graph is given like this. This height would be 5 meter, which means the insect covers 1 meter in 2 seconds. After 2 seconds, it covers 1 meter, and the next 1 meter it goes on like that. Keep in mind that this is not the motion of the ant itself, rather it is a motion of the displacement. If you call the excess the displacement in this direction, it is the graph of displacement versus time. So it takes to go to highest point in 10 seconds, which means the maximum distance covered would be 5 meter in a time of 10 seconds. Similarly, if it comes downwards from highest to lowest point, x would decrease. I'm taking x as vertically upwards, it will decrease. So the distance will decrease, time will increase. It comes back here, comes back in next 10 seconds. Again it stops and then turns back immediately and goes. The motion will repeat itself. As seen here, even this is a periodic motion. Here the time period is 20 seconds. Now there are many more such examples of periodic motion. What is given here is just few examples, but keep in mind that whenever some motion repeats after a definite or regular time interval, then those motions are called as periodic motions. The next topic is the difference between oscillations and vibrations. These words are used interchangeably, so they mean the same thing. That is, whether it is oscillation or vibration, it basically means that it is the to and fro motion about a mean position. That is called as oscillation or vibration. But we use vibration to mean an oscillation of very high frequency. To understand this, imagine that the spring which is given in the early example, now this spring example starts from this point and goes to this point. Let's call this point B and point C. It starts from point B and goes to point C and comes back to point B. That is called as one oscillation. Now, if you take a time period, if you take, for example, in 1 second, you find out how many times it oscillates, that's called as frequency. So, the number of oscillations done in 1 second is called as its frequency. If the frequency is small, that's called as oscillation. The frequency is high, then it is called as vibration. For example, if we look at, say, the oscillations of a tree branch, that will have a very small frequency, so it's called as an oscillation. The frequency is high. For example, let's take an example of a solid where there are atoms present. Now each atom will oscillate about its mean position. For example, think of this atom. This will oscillate like this about its mean position. Even this will oscillate like this. So every atom will oscillate. But in this case, the number of oscillations made per second is very, very high. So this will be called as vibration. But technically, both of this mean the same physical phenomenon, which is a to and fro motion, but based on frequency we differentiate it. Again, there is no clear boundary here, which means we can't have a cutoff frequency stating that something below this cutoff would be oscillation and something above cutoff is vibration. It is not possible, just a broad understanding. There is no cutoff frequency. Now here are some examples of oscillatory motion. Example 1 says the motion of the bob in a simple pendulum. To understand this, consider a case where there is a rod or any point of contact to which a string like a rope or a wire or say thread is attached, and to this mass is fixed. Let's call this as position A. Suppose if the string is pulled to some position like this and let it from there, we leave it from here, this will start to oscillate. It will cross point C and go to point A. It will cross point A, go to point B. It will stop from there and return to point C. So, starting from point C, it will cross point A and go to point B. Again cross point A and go to point C. That is called as one oscillation. In this case, even this would be an oscillatory motion. Second example is when a loaded spring is pulled and then released. The load attached to the spring executes oscillatory motion. We saw it earlier that if you take a spring and attach a mass to it, this is called as loaded spring, which means some mass is attached to the spring, and then if you pull it down and leave, it will start to oscillate. One example given here is when a piece of wood floating over a surface of water is pressed down and released, it executes oscillatory motion, which means, think for example like a tub contains water, and imagine that there is a small piece of a wooden cube floating. If you press and leave it, if you draw its side view, if you press the wooden cube and leave it, it will oscillate. Because of resistance, it would die down soon, but if you assume a case where there is no viscosity, then it will keep on oscillating. Even this is example of a oscillatory motion. Now, let us look at some cases where the motion is oscillatory, which is periodic. We already learned that oscillatory motion are nothing but part of periodic motion. Example would be the pendulum of a clock. Even the pendulum would oscillate between two ends. Even this is a periodic motion. One example is motion of a needle in a sewing machine. Even the needle in a sewing machine would be a oscillatory motion, which is periodic. One example is oscillations of a torsional pendulum as given here. This kind of arrangement called as torsional pendulum, where we have a disc attached to a string. Suppose if we rotate it by an angle and leave it, it will start to oscillate. It will go like this and then come back. It will oscillate. Even this is an oscillatory motion, which is again periodic motion. One example is to and fro motions of atoms and substance. So basically every oscillatory motion is a periodic motion, and here are just few examples given of the same. Next question is, are all periodic motions oscillatory? We learned that every oscillatory motions is periodic, but other way around, are all periodic motions oscillatory? The answer is no. There are many periodic motions which are not oscillatory. Examples of these are uniform circular motion. For example, if you assume that a particle moves in a circular motion, for example, think of here a center of circular motion, and a particle, think like an electron moves around the nucleus. So in this case, the electron would move in a spherical orbit, but here if you take in 2 dimension, think it moves around this orbit. So this is nothing but a circular motion, which is not oscillatory motion. One example could be orbital motion of planets in the solar system. That is, the orbital motion of the planets like Jupiter, Earth, Mars, whatever it is. In all the cases, they move in a certain elliptical orbit. Now these are periodic motions, but not oscillatory motions.